Today I'm going to solve the LeetCode question 125, valid palindrome. A phrase is a palindrome if, after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. Given a string S, return true if it's palindrome or false otherwise. So we have this string here, man, plan, a canal, Panama, and after converting all the uppercase characters into lowercase and removing all non-alphanumeric characters like this comma and this colon, we are left with this string, and it turns out it is a palindrome, because it reads the same forwards and backwards. Okay, and similar for race a car, it's not a palindrome, and here S is an empty string after removing non-alphanumeric characters, and since an empty string reads the same as forward and backward, it is a palindrome. Okay. So there are two steps in solving this problem. So one, do as the problem describes up here with the string, convert all uppercase letters to lowercase and remove all non-alphanumeric characters. Okay, and once we have that modified string, the second part is detect if it's a palindrome or not. And to do that, we can use a two-pointer approach. So starting from the very beginning of the string and the very end of the string, for example, if we have A, B, A here. So we have our beginning pointer here and an end pointer here. And what we do is check if these two characters are the same. If they are, move this beginning pointer to the right and this end pointer to the left and make them converge, and eventually they'll be at the same character here, B. B is equal to B anyway, so once again we move our start pointer will be at A and will be at A, and since our beginning pointer is at a position greater than the end pointer, we can stop there. Basically, we know from the left and the right side of the string, it is a palindrome. Similar idea if we have a valid palindrome of even length. We have our start pointer here, our end pointer here. They're the same, and converge in the middle. So now start is here, end is here. They're the same, great. And now start is here, and end is here, and since the position of start is greater than end, we can stop there. Now to code this up, so first thing we're going to do is scan through the string. Oh, I forgot to mention that this solution is O of n solution. It's linear time, where n is the length of the string S, because we do have to look at traverse the entire string and look at each character once. So first thing to do is modified S, have that be empty, and I actually want to check if S is empty. If len, I can check that after modifying the string. So modified string goes that, and for char in the string here, if char dot is al num, this is alpha numeric. This is a nice shorthand in Python to check if a character is alphanumeric, if it's a letter or number. Modified S plus equals, and we want to make sure that char is lowercase, equals, Actually, instead of individually lowercase in each character, I can just lowercase the entire string. S dot to lower. Okay? So now all the characters should be lowercase. So for each character in S, if character is an alphanumeric, we append S to the modified, we append char to the modified string variable. And now, so this step was to modify string, and this step will be verify if palindrome. Okay, so our start pointer will be at position 0. Oh, and first I want to check if len modified s equals 0. Does that mean it's an empty string? Return true, like in this case here. So now we're going to initialize our start and end pointers. Start will start at position 0 of this modified string, and end will start at the end position -1, or -1 because it is 0 indexed. And while start is less than or equal to end position of the pointer, we check if, we'll copy paste here, modified s, if the character at the start pointer is not equal to the character at the end pointer, return false. And if this condition is not met, we can increment start and decrement end. And once all that's done, if we still haven't gone through this condition, we can return true. Okay, let me try compiling it. Has no attribute to lower. I might be forgetting my syntax here. It should be just lower actually. Now let me try adding some print statements. Check if S is actually lowered. No. How about now? Okay. Now it turns right. I just need to reinitialize S there to the lowered version of itself. So I'm just going to try this with all the test cases. Okay, now I'll try submitting it. Okay, great. Thanks for watching.